For the ram type, the actuator is installed in the steering gear compartment directly above the rudder. The rudder stock connects the rudder with the rudder tiller, and the rudder tiller connects the rudder stock to the actuator. On the rotary vane type, the actuator is situated on top of the rudder stock in the steering gear compartment. The rotor in the rotary vane actuator is mounted directly on the rudder stock. The rudder stock connects the actuator with the rudder. This is the rudder stock. This is the watertight packing gland and rudder carrier bearing fixed to the hull structure. These are the actuator supports. Here is the tiller. The tiller can be fitted to the rudder stock in different ways, such as a tapered hydraulic fit, by key, by bolts, or a combination of these. These are the ram cylinders with pistons. Here are the high-pressure hydraulic pipes. Here are the high-pressure hydraulic pumps with their electric motors. More hydraulic pipes. And finally, the oil reservoirs. The ram-type steering gear system is now complete. The steering gear also has a control system consisting of several hydraulic and electric components, securing safe operation and maneuverability of the ship. The steering gear and the control system are supplied with power from the supply panels in the steering gear compartment. Larger ram-type steering gears usually incorporate a device known as a Rapson slide. The purpose of the Rapson slide is to convert the linear motion of the rams into circular motion at the tiller. Each set of two opposing ram cylinders is connected by a guide bar, which the crosshead guide swivel blocks slide along. The guide bar ensures that no sideways force is transmitted back to the rams, which could cause them to bend and damage the gland packing, leading to leakage of hydraulic fluid. The guide bar can sometimes be designed to include the steering gear stops to limit the maximum travel of the steering gear and rudder, and may sometimes be designed to lock the rudder in position, either in an emergency or for maintenance. Smaller ships sometimes use floating rams, which have ball joints at each end to operate the tiller. The ball joints are needed because the positions of the rams will change as the tiller rotates. On very small ships, only one double-acting ram or two single-acting rams may be used to steer the ship. The design allows more freedom in layout. The main problem is that the hydraulic connections to the rams must also be flexible. This usually means the use of flexible hoses. These do not last as long as the solid pipes used with rams using a Rapson slide. It is also necessary to ensure that the rams are not bent or deflected by any vertical forces, so ram-type steering gears always need a separate rudder carrier bearing to support the weight of the rudder. The carrier bearing is usually designed to take up at least some of the radial load from the rudder stock in addition to the weight of the rudder, and therefore has both radial and horizontal bearing surfaces. The alignment of the rudder stock is sometimes assisted by using a bearing surface which is conical in shape. With modern bearing materials, there should be very little wear on the rudder carrier bearing. If the carrier bearing does wear, however, then the rudder and rudder stock move downwards, so there must be enough clearance between the bottom of the tiller and the bearings in the Rapson slide to avoid the weight of the rudder being taken by the rams, which would bend the ends of the rams downwards and lead to leakage of hydraulic fluid. The wear-down clearance of the carrier bearing is important and needs to be checked in dry dock, and measuring gauges are sometimes provided with the steering gear for this purpose. There is also clearance at the top of the Rapson slide arrangement, so that if the rudder should be lifted by wave action in heavy weather, its upward movement will be stopped by its clearance to the hull before exceeding the clearance to the Rapson slide, sometimes referred to as the jumping clearance. It should also be checked during dry dock. This is the rudder stock. It is tapered on top to fit the rotor. This is the rotor. It is usually mounted to the rudder stock by the use of a tapered hydraulic fit, but different ways, such as a key, bolts, or a combination of these may be used. These are the bearings for the rotor, upper and lower radial bearing, and the rudder carrier. This is the actuator housing. These are the stopper mounting bars. These are the stoppers, which serve a dual purpose. Together with the rotor vanes, the stoppers divide the actuator into pressure chambers and also make boundaries for the maximum rudder angle. This is the lower packing gland. This is the base for the actuator. This cover forms the top of the pressure chambers. This is the ring jack. It is used during installation to force the rotor onto the rudder stock. This is the rudder stock nut. This is the mounting plate for the angle indicator. This is the angle indicator shaft. This is the system oil expansion tank. This is the angle indicator wheel. These nuts lock down the cover stoppers and oil gasket. With these, the actuator is complete. Please be aware that the actual sequence for assembling the actuator is different from the sequence shown here. Click on the sectional drawing of the rotary vane actuator for information about the different parts.